Hello everyone, let's talk about another medium problem on Leetcode today. Balance a binary search tree, Leetcode 1382. In this, we are given the root of a binary search tree, which may or may not be balanced, but we have to return the balanced binary search tree. And then they have defined what does balanced binary search tree means. A binary search tree is balanced if the depth of two subtrees of every node never differs by more than one. It can have multiple answers. In example 1, we can see that we have a skewed binary search tree such that all the nodes have only right child and there is no left child. So it's like a linked list or something, but yeah. And it can give multiple height balance trees, and any of these can be a valid answer. So it either we return one binary search tree with 2 as a parent, or we return another binary search tree with 3 being a parent. Now that we have seen the examples, let's jump into the solution space. Because it's a binary search tree, when we run the in-order traversal, it will be in the increasing order. And whether it's a skewed binary search tree or a balanced binary search tree, it will always be the same. So for this skewed tree, it will be 1, 2, 3, 4. And then for these balanced trees also, it will be 1, 2, 3, 4. So it returns the values in the increasing order. So how about we actually reuse one of the solutions we have already solved? That is, convert the sorted array to height balanced binary search tree. Please check that video out by clicking on the I button. We will actually reuse that solution here. Now the solution becomes twofold. First, we run the in-order traversal on the given tree. So that will give us the array in the increasing order. So that will be like a sorted array. And then we actually convert it to balanced binary search tree using the solution we have already covered in Leetcode 108. That is, convert sorted array into the balanced binary search tree. Now let's jump into the code part. So first thing we will do is we will run the in-order traversal. Just pass a root, and we can collect the values in the list of tree nodes. We can also use a list of integers here, but we are using list of tree nodes so that we don't have to create the tree node values from these integers in the future. We can directly just reuse the same tree node objects. Also note that I'm using the list here and not the array. The reason I'm using a list here and not array because we don't know the size of the list yet, and in Java when we are creating the array we should know the size of the array. So a tree list, we can practically write the same algorithm with a array list as well. So let's create it. So when we do the in-order traversal, we will just pass the root to it, and in in-order traversal we first process the left child, then the parent, and then the right child. So we will just follow that, but the base condition is that root or the current value should not be null. In that case, we will just return. So now we will process the root.left. Then we will process the parent. So we will just edit the sorted list. Now we need to process the root.right. Now that we have a sorted list, we can convert it to balanced binary search tree. So what we can do is we can just say return sorted list to BST. And here we can pass 0 and sorted list.size -1, like a left and right pointer to the previous solution. And we will just write this method as well. So we will just return tree node, pass the low and high values for the 2-pointer approach. And if at any point low is greater than high, that means we have covered all the elements now in that part of the subarray. So we will just return null in that case. But otherwise, we will just find the midpoint and get the tree node from the list for that midpoint. That's the advantage of using tree node in the list, so we don't have to create it. Of course, some interviewers may not be fine with it, so just check with them. So if they prefer immutability, better to create a new instance itself. And now we will just recurse to the left and right side. So it will be again low to mid -1 for the left side. And for the right side, it will be mid +1 to high. That's it. I think then we are done. And in the end, we will just return the root. So let's run this code now. There's some error here. Okay. Let's run it again. Cool. Let's submit this code. Awesome. In terms of time complexity, it is O of n, where n is the number of nodes in the binary search tree. Because when we are doing the in-order traversal, we are visiting each node only once, so that will take O of n time. And then we are actually again converting it to the balanced binary search tree. That takes again O of n time, because we are visiting the same nodes again only once. And then in terms of space complexity, it will be O of n as well, because one is a recursion stack. And second thing is we actually also use this sorted list to store the values. I hope this was clear to you. If it was useful, please like and subscribe. Have a nice time. Thank you.